Imagine a lithium-ion battery as a tiny, rechargeable energy storage device that powers your electronic gadgets, like smartphones, laptops, and electric cars. It works like a tiny, rechargeable energy tank. Here's how it operates. Electrolyte, and between these two sides, there's a special liquid called an electrolyte. It's like a bridge that allows some tiny particles called lithium ions to move back and forth. Energy flow. When you use your device, the battery starts working. Electricity flows out from the negative side, anode, into your gadget, powering it. Think of it as energy flowing out of the battery to make your device run. Charging. When you plug the battery in to recharge it, the process goes in reverse. The energy flows back into the battery, filling it up like a gas tank. The lithium ions move from the cathode to the anode through the electrolyte. Safety layer. There's also a special safety layer inside the battery that keeps things stable and prevents fires or other problems. So, in simple terms, a lithium-ion battery stores and releases energy by moving tiny particles, lithium ions, between two sides while using a special liquid, electrolyte, as a bridge. This process allows your gadgets to work and be recharged. It's a bit like how a gas tank stores fuel for your car, but instead of gas, it stores electrical energy.
Hello, I have been asked by my creator, Mr. Ronan Azam, to talk a little about the connection between computer science and lithium-ion batteries. With the use of computer science, we managed to create a battery management system that functions as the brain of a lithium-ion battery. It's a computer-based system that keeps the battery running safely and efficiently. Here's how it works. Firstly, data collection and monitoring. BMS uses sensors to collect important information from the battery, like how much charge it has, how hot it is, and how much power it's delivering. Second, BMS processes and analyzes this information, tries to look for patterns, and figures out how healthy the battery is and its performance. Thirdly, the data is shown in a user interface, as in this image, indicating the car's charge or energy level as a percentage. Cell balancing in a BMS for lithium batteries revolves around the equalization of energy levels among individual battery cells. Over time, cells may exhibit variations in their energy capacity and performance. Cell balancing aims to balance the energy state of all cells, ensuring that they have equal energy levels. This optimization maximizes the overall energy performance, capacity, and safety of the battery pack by redistributing energy among cells through passive or active techniques.
Hello, I'm Rasida Sarno. Let's talk about the ecological effects lithium-ion batteries. Lithium-ion batteries, while offering numerous advantages, have several ecological impacts. These impacts arise from mining, production, usage, and disposal. Mining habitat destruction. Extracting lithium involves significant land disruption, which can destroy habitats. This process also uses a lot of water, affecting water supplies in the area, especially in desert areas. Mining can also result in soil, water and air pollution due to the release of toxic chemicals. Production. The production process of lithium-ion batteries can lead to waste products and emissions that can be harmful to the environment. Disposal. If not properly recycled, lithium-ion batteries contribute to the growing e-waste problem. Currently, recycling processes for lithium batteries are not fully efficient, leading to the release of metals and chemicals into the environment, which can to fire risk and other destructions. Usage. While the batteries help reduce car pollution, if the batteries are charged using electricity from non-renewable sources, like coal, it reduces the environmental benefits. Ethical problems. In recent years, there have been reports of unethical activities at lithium mines, such as mistreatment of miners, overuse of freshwater sources, and the destruction of local ecosystems.
One way to mitigate ecological consequences caused by the extensive use of lithium-ion batteries is solid polymer electrolytes. Think about it as an upgrade to standard lithium-ion batteries with some natural carbon compounds added. These upgraded batteries exhibit higher thermal and electrochemical stability, increasing the efficiency of these batteries and, thus, the ecological impact of their overuse. One of the polymers used to create such batteries is cellulose. Certain structural characteristics, specifically an abundance of hydroxyl groups, allow to prepare the electrolyte matrix via a process known as Lytin-controllable polymerization. To address battery pollution, researchers explore microbial fuel cells that convert organic compounds into electricity using microorganisms. Some aim to merge these cells with lithium batteries, creating hybrids that generate power from organic waste, reducing our reliance on fossil fuels and mitigating climate change.
A lithium-ion battery is a type of rechargeable battery that stores energy through the movement of lithium ions between two electrodes, typically composed of a lithium cobalt oxide cathode and a graphite anode. The chemical reactions that occur during charging and discharging involve the transfer of lithium ions and electrons between the two electrodes, which creates a flow of electrical current. Lithium-ion batteries rely on reduction-oxidation reactions to store and release energy. During charging, lithium ions are removed from the cathode and inserted into the anode, while during discharging, the process is reversed. The reactions that occur at the anode and cathode are governed by the chemical properties of the materials used. Lithium is relatively unstable in its natural state and tends to lose electron, while cobalt peroxide has +4 charge and tends to receive electrons. Lithium is the anode and cobalt is the cathode. The electrons move from Li to Co, which creates energy we use. After that, the positive Li ions are attracted to the other side and move there through the isolator, and when we charge the battery we move the electrons back and Li also moves back and the cycle starts again.